There are some well-known power series which are useful to get to know because they do show up a lot and we can sometimes use these to build other series. The first one that we have here is 1 over 1 minus x. And the reason why that comes up is because that's kind of our first power series, and it's just a basic power series without a coefficient. And it comes from our infinite geometric series. And so this only converges when x is between -1 and 1. The next one here, e to the x. E to the x is, we can use, and it's useful because we can use this again to build other series. But this one has a factorial in the denominator. And because that factorial, it does converge very quickly, and it does end up converging for all values of x. So compared to the first one that has a domain from -1 to 1, the e to the x function, that series happens to converge for all x. So it's x to the power n, so the power series with a 1 over n factorial as the coefficient. The third one, log x, is a power series, but it's been shifted because we can't have x equal to 0 for log. And then we have for the coefficient, we have -1/2, +1/3, etc. It is an alternating harmonic series. And again, alternating harmonic series do converge. So we have that part there being the alternating harmonic series part. Sine x and cos x are also very useful ones. They show up a lot. They're very common. And one thing to note about the sine and cos is that sine is all the odd powers. So sine skips all the even ones. We just end up with odd powers. And just make a note that it has this factorial expression in the coefficient. And so it does converge, and it does converge for all real numbers. And for cosine is an even function, has even symmetry, so it just uses the even powers. And it's very similar to the sine x function. And then lastly, I have arctan, and arctan is not as common, but arctan looks very similar to the sine function, but note the difference in that arctan uses that harmonic series in the denominator instead of a factorial series.